Okay, guys, for today's lesson, we're going to do ratio comparisons. So we've talked about qualitative versus quantitative, part-to-whole ratios. Today, we're going to start rank ordering them. So we're really going to focus in on what we're doing. For us, our homework is going to be 191, 192. Our first one we're going to order part-to-part and part-to-whole ratios. So if you guys will all turn to page 189, you're going to tear that page out in your book, and you're going to cut it into small strips. But everybody look at me real quick. I want your attention before we get started on this. Here is our task. We are going to order the cards from least lemon lime to most lemon lime. If you think more than one card describes the same ratio, group those together. So we're going to order the cards least to most based on lemon lime. Cards that have the same ratio we're going to put together. I'm going to add to your task, though. This is why you need to be looking at me. Thank you. So we're going for every ratio card, we're going to do three things. The first one we're going to do is write it in words. Second is write with a colon. Third is write as a fraction. Okay? So I'll give you a couple examples. You guys will all look at card A on your sheet. It says, for every lemon lime soda, there is a pineapple juice. I'm going to give you another hint. Why all of these is part to part. In order to compare, you need to have the same type of ratios. So there's a few of these that give you part to wholes. You'll need to switch to parts for those. In this case, every lemon lime, there is a pineapple. They've already done number one. They did it in words. To write it with a colon, 1 to 1. To write it as a fraction, whatever number comes first goes on top. Whatever number comes second goes on bottom. Simplify, but because these are ratios, we're always going to keep two numbers because a ratio has to have two numbers to compare. Does that make sense? So I won't simplify that any further to 1. Our second one, if I look at my picture, I have how many lime?
2.
So in words, for every 2 lemon lime, there are how many? 4 pineapple. I now have it written in words. Now I can do this as a ratio with a colon. So that's going to be 2 to 4. Turn it into a fraction. The first number comes first. Second number goes in the denominator. Simplify where you can. I can divide both those by 2. So my fraction becomes 1/2. Does that make sense to everybody? So you are going to first you're going to cut these into small pieces. So every card is by itself. You're going to write the ratio in all 3 formats. If you write really large, you can write it on the back of the card in words, but there's plenty of room on the front to do the numbers. So you should have the colon format and the fraction format. Then you're going to rank them from least lemon lime to most lemon lime, putting any ratios that are same in the same line. Everybody clear? Okay, this will take a little while, so I'm going to give you guys about 20 minutes to do this activity. Okay, you have 20 minutes. Go ahead and start. You may work together as a table. Okay, we're going to go through this. I'm going to show you what you should have had written on each of the papers, and then we will actually do the rankings from least to greatest. Okay, so part A and B we've already done. C says 1/4 of the punch is lemon lime soda. But I told you up front, make them all part to part, correct? Because I have to have the same type of ratios in order to compare them. Does it make sense? So if it's 1/4, is that a part to part or a part to whole? That's a part to whole. So there's 1 part of lemon lime, so I know that, but it's 4 total, so what's the part for pineapple? 3. So then I write it as a fraction, 1/3. My next one, they gave me a picture, so I need to write it out. So for every 4 lemon lime, there are 5 pineapple. So writing that as a ratio, that then becomes 4 to 5 as a fraction, becomes 4/5. E, half the mixture is pineapple. Is that a part to whole or a part to part comparison? If I say half of the mixture, Yahi. If I say half of the mixture, that's going to be part to part or part to whole? Part to whole. Because it's talking about the mixture, right? So I know that half is pineapple, so one of them is pineapple. There's 2 total. So how many lemon juice is there? 1. So that one becomes a 1-to-1 or 1/1. Our next one, again, we have a picture. So I'm going to say for every 2 lemon lime, there are 3 pineapple, which now becomes 2 to 3 or 2/3. Our next one says lemon lime soda to pineapple juice. They gave us words. It's 4 to 5. They gave us the colon. So now I just need to write as a fraction 4/5. Our next one, they gave us another picture, so we need to start with words. For every, how many did they picture? 2 lemon lime. There are 2 pineapple. So that one starts as 2 to 2, turning it into fraction, 2/2, which I can simplify to 1-to-1. Again, we leave it as a 1-to-1. I don't go all the way to 1 because for a ratio, I have to have 2 numbers. Remember, a ratio is a comparison of 2 numbers by division. I, they said for every lemon lime, there are 2 pineapple. So they gave it to us in words. Should have been really straightforward. Every means how much? 1. So when you see that word every, mathematically, you should associate that with the number 1. There are 2 pineapple. As a fraction becomes 1/2. Let me write that one because we need that to make sure everybody knows that's a 5. For every lemon lime soda, there are 1 1/2. So that one is 1 to 1 1/2, which becomes a little more problematic as I write it as a fraction, right? Can I actually have a mixed number in my denominator? Technically, I can. We call that a complex fraction, but I really shouldn't. So what they've done is they've oversimplified. So now I'm going to actually expand this one back out so that I get 2 numbers. 1 1/2, if I double that, is going to give me 3. But if I double that, then I also have to double the top. So that gives me the same as 2/3 in fraction form. Does everybody see that? That was probably the single hardest one on there. Okay? Okay, it says pineapple juice to lemon juice is 3-to-1. But how are we doing our ratio, guys? Which part goes first? Lemon lime. What did they list first? Pineapple. So for our purposes, we need to switch that so that we can do our comparison of lemon lime to pineapple. Should be 1/3. And then our last one, 3/5 of the punch is pineapple juice. So again, they've given us a part to whole, right? 3/5 of the punch. And they told us the part that's pineapple is 3 of the 5. So how much is lemon lime? 2. So my ratio comes back to 2 to 3 or 2/3. Does everybody understand where all 3 pieces of each of those came from? Yes. Now normally it would have been a big deal, but because we are ordering them, we need our ratios to all be the same type and in the same order so that I can do a comparison. Does that make sense to everybody? Okay. So now that I have them all in the same type and the same order, we can look at to me, I start at the fraction because that's easiest for me to compare because that's what I really think of in numbers when I'm comparing. So if all of them I've written, I've got 1 over 1, 1 over 2, 1 over 3, 4 over 5, and that's all the numbers I've got, right? So of all of those, which one is the smallest? Legend? Nope. 1 to 1, it's not, is it the biggest? Yeah, I think it is the biggest. Samuel? No. Jaden? 1 to 3, 1/3, guys. So 1/3, I actually have a couple of those. C is at 1/3. And once I've done it, I'm going to cross it off so I can keep track. And K is at 1/3. So I have 2 of them at 1/3. Then I need to look what's the next smallest. 1/2, 2/3, or 4/5. 1/2 should be my next smallest. I said 1/2, 2/3, or 4/5. Because those are the fractions I've got stuff still remaining. Right? So 1/2 is my next smallest. I see a 1/2 for B. I see a 1/2 for I. That's all the 1/2s. Okay, so now we're down to 2/3 and 4/5. Which one of those is smaller? 2/3. Again, we'll go back to last class. If I'm dividing it into 5 sections and I've got 4 of them, that's going to get me closer to 1 than doing 3 sections and 2 of them, right? So 2/3 is my next smaller one. So for 2/3, we had F. We also had J. No, it wasn't. Yeah, it was. F, J, and L are all 2/3, aren't they? Then I have 4/5. We had 2 of those. We have D, and we have G. And then for 1s, we had A and E. And what did we do here? And H was also 1. So we had 3 there as well. Make sense? Does everybody understand all of the parts of what we did? Which part don't you get, Samuel? Okay, let's do a quick thumb meter. How are we looking, guys? Okay, a lot of mids, which is kind of what I expected. So we're going to do an extra activity today. Okay, before we do our extra activity, let's look at this one. So I'll come around with the trash can for you to throw them away, or you can keep them, your choice. You don't have to throw them away. You can keep them if you want to. Guys, we're now going to do a penalty shot scenario. Very appropriate with World Cup going on right now. So a soccer team was awarded a penalty shot at the end of a tie game. If the team makes the penalty shot, it will win the league championship. The coach is considering 3 players to take the penalty. Amber has taken 4 penalty shots this season and made 3. Lindsay has taken 6 penalty shots and made 4. Lee has taken 3 penalty shots and made 2. Which player would you recommend? And explain your choice. So you got 2 parts. This one should take you about 5 minutes. So you guys like 5 minutes to work this one out. Yes, we're going. Let's look at this one. Now, we're going to, guys, we're going to look at this one mathematically for our choice. So we have 3 different people. We have Amber, we have Lindsay, and we have Lee. So if I look at these from the perspective of how many they have made out of what they took. So Amber has made 3 goals out of the 4 she has taken, or 3/4. Lindsay has made 4 out of the 6, or 4/6. Guys, please quiet down. Which simplifies to 2/3. Lee has made 2 of the 3, or 2/3. So which one do you want taking the penalty shot that's going to win the championship for the year? Why Amber? Why? You're supposed to explain your reasoning. Autumn? So why Amber? Okay. Jaden? Could do you could make percentages out of them. Technically they'd run to 67, but yeah. Which is probably how I would look at it. I would probably look at percentage. She's made 75. These two are the same at 67%. So Amber has made the highest number of goals. In other words, she has made 3 out of 4, which is 75%, versus 4 out of 6, which is 67%. Does everybody understand the reasoning and how you get it? Okay, let's look at the sheet I just handed you. This is what you're going to be doing for about the next 15 minutes. There's 3 parts to this sheet. Part 1, determine whether it's additive or multiplicative. Does it say anything about giving all the reasoning? No, this is just an example so you can understand why they're saying this is additive. Do you have to write that for all of them? No, you don't. Guys, this is really easy. You read the problem. Is it additive or multiplicative? Second part. Nina, she's got a box that contains 5 blueberry, 3 strawberry, 2 apple. Write the ratio that writes each relationship in words, in colon form, and in fractional form. So just like we did earlier in our activity. You're taking each of these, you're writing it in all 3 forms. Is everybody okay on that? Those directions go onto the back page for 11 and 12. Your last part, write a part to part and a part to whole. So you're doing 2 of them for each problem. So they gave you an example on number 13. They actually did that one for you. But for 14, 15, and 16, you're doing a part to part and a part to whole. Everybody clear? Yes. Okay, you have 13 minutes. Go. Okay, let's go ahead and really quickly, before we go over that piece, go to page 191. This is your homework. 191 and 192. Let's go hit the highlights. For your journal entry, describe qualitative versus quantitative. If you've forgotten the definitions, they're in your book. We put those up with highlighters a couple days ago. Number 1, Megan is making a fruit punch using fruit juice and ginger ale. She tries different combinations to get it just right. If the ratio of fruit juice to ginger ale is too high, punch is too fruity. If it's too low, the punch is too gingery. Here's your key. For each attempt, you're going to write the ratio. She can try next time. In other words, you're going to change the ratio based on what they've given you. She said it was too fruity. So that means I need to do what? Either less fruit or more ginger ale, right? So we're going to understand that concept. That's what we're doing for all of these. So here's my recommendation. Write the ratio they've given you, simplify it, and then just change it based on what they've given you. You're going to do that for all 4 of those. Then on number 2, based on our attempts, what might be a good ratio? So you can see what was too high, what was too low, and you can get yourself into an in-between ground that should give you a good ratio for that. Does that make clear? Big key piece here, explain your reasoning. So you can use your other attempts as your examples. Turn to the next page. This one's super easy. Literally, all you're doing is writing them least to greatest. My recommendation, turn them all into fractions and simplify. If you have them all in simplified fractions, the ordering should be very easy. Okay, let's go to what you guys just did. Let's go through as many of these as we can in the next couple minutes before the bell rings. Number 1, our first problem set. All we had to do is write multiplicative or additive. So Juan has 7. LaTanya has 4 times, or 28. That would be multiplicative. Second, Melanie's 8. Justin's 4 years older. That's additive. Third, Tim ran 15, which is 3 times as many. That means it's multiplicative. Akira made a really good point on number 5. This one you can actually look at either way, but based on the language they used, they scored 20 in the first half and twice as many in the second. Twice is multiplicative language, although you technically could have added that one as well. But based on the language, we'll call that one multiplicative. The temperature 70, it rose 3. That one is additive. Everybody should have gotten those correct. Our next part, we're going apple to blueberry. Apple was 2, blueberry was 5. So that would be 2 apple to 5 blueberry. As we put it into a fraction, 2 fifths. Yeah, a lot of trouble with apple today for some reason. Apple to blueberry. And then in words, we could say something like, for every 2 apple, there are 5 blueberry. Does everybody understand this concept of how to write all the different forms?
Yes.
Okay. Strawberry to total. Strawberry was 3. So that's 3 strawberry. Total, if you add them all up, you get 10 total, which we could write with a colon and as a fraction. And the last one, apple to total. Apple was 2. 2 apple for every 10 bars. Or 2 apple to 10 total. Or 2 apple over 10 total, which we could simplify, dividing by 2 to make it 1 to 5. Everybody good on this side? Okay, turn it over. Let's look at our back. First, we did blueberry to total. Blueberry was 5, correct? So 5 blueberry out of 10 bars. So we have 5 blueberry to 10 total. Or as a fraction, 5 blueberry to 10 total, which we could simplify, divide those by 5 to give us 1 to 2. Apple to strawberry, so that was 2 apple bars for every 3 strawberry. As a ratio, 2 apple, using a colon, to 3 strawberry. And as a fraction, 2 apple over 3 strawberry. You guys getting these concepts? Ratios should be really easy, guys. It's literally just writing them in the order they were given to you. And then our last part, they already did this one for us. So this one, part to part, would have been 23 fiction. So that's time. You can either use that sheet to continue to practice. Make sure you get your homework done. It should be relatively easy, guys. Good luck.